This is going to be a video key for our wrap up of units, this unit circle for section 8.3. So these were the problems that you were left to do on your own. So just in case anyone had any trouble, this key will just kind of talk you through that. So what trig functions are positive for angles ending or terminating in quadrant 3? So I'm going to remember all students take calculus, and I'm going to know that tangent is positive in quadrant 3. Which trig functions are negative for angles ending in quadrant 4? Well, if cosine is the trig function that's positive in quadrant 4, then that means sine and tangent are negative. All right, this asks if cosine is greater than 0. Guys, that essentially means cosine is positive. Which quadrants would the terminal angle lie in? So cosine is positive in quadrants 1 because everything's positive in 1, and quadrant 4. The next question, number 4, says if secant is less than 0. So basically that means if secant is negative, which quadrants could the terminal side of the angle lie in? Secant's value is going to be the same as cosine's sine value, and cosine is negative in 2 and 3. That means secant would be negative in 2 and 3. All right, here's some more of the unit circle practice where you need to, know those ratios, know what quadrant you're in, so on and so forth. So we've already done some of this together, but here's my thinking. Cosine of 60 is 1/2. 1/2 is in quadrant 1, so it's positive. Negative 225, this is a 45-degree reference angle. I know the tangent of 45 is 1. And I know negative 225 is in quadrant 2, where tangent is negative. 330 is a 30-degree reference angle, and I know the sine of 30 is 1/2. 330 is in quadrant 4, and sine is negative. Here's a reciprocal function, so I'll take an extra second here. I'm going to think about the cosine of 210. This is a 30-degree reference angle, and I know the cosine of 30 is radical 3 over 2. I know 210 is in quadrant 3, where cosine is negative. So if I do the reciprocal of this, I'm thinking negative 2 over radical 3. I'm going to rationalize negative 2 radical 3 over 3 would be the final answer here. Another reciprocal, I'm going to think of this as the sine of 225. This is a 45-degree. I know the sine of 45 is radical 2 over 2. 225 is in quadrant 3, where sine is negative. So as I do the reciprocal, I'm going to keep that negative and flip. As I rationalize, I get negative 2 radical 2 over 2, and I simplify to negative radical 2. Go ahead and circle these ones. All right, one more reciprocal here. Cotangent, I'm going to change to it being a tangent. And the tangent of 210, this is a 30-degree in quadrant 3. I know the tangent of 30 is radical 3 over 3. And in quadrant 3, tangents are positive. So as I flip this for the reciprocal, I get positive 3 over radical 3. Rationalized 3 radical 3 over 3, cancel the 3's, and I get radical 3 at the end. So those reciprocals take just a little bit longer and some more thinking. All right, moving on. Tangent of pi. So again, pi is one I don't have memorized, but I'll draw the ordered pair at 180 mark, negative 1, 0. Tangent is the y over the x. So 0 over negative 1 equals 0. Sine of, this is a 45 because it's a pi over 4. So I know sine of 45 is radical 2 over 2. Negative 5 pi over 4. Again, I'm going to compare to 4 pi over 4. Negative 5 would have been in quadrant 2 where sine is positive. Oh, another reciprocal here. So I'm going to think about cosine of pi over 3. This is a 60-degree angle, and the cosine of 60 is 1/2. This is in quadrant 1, so it's positive. So when I do the reciprocal, I simply get 2. All right. Cosine of a 5 pi over 6. Pi over 6 is a 30-degree. Cosine of 30 is radical 3 over 2. And then 5 pi over 6, if I compare to 6 pi over 6, quadrant 2, cosine is negative. Tangent of pi over 2, that's 90 degrees. So this ordered pair is 0, positive 1. Tangent y over x, so I get 1 over 0. This is undefined because I cannot divide by 0. Cosecant, I'm going to think about sine of 11 pi over 6, and this is a 30-degree. Sine of 30 is 1/2. 11 pi over 6, here's 6 pi over 6, and then here's 12 pi over 6 at the 2 pi mark. 11 pi over 6 would be in quadrant 4, so that's a negative. So I'm going to go ahead and flip that, and that'll give me a -2. All right, so here's some of the new problems that we just learned today. So I'm going to give you one of your trig ratios. You're going to find whichever one I've identified for you. So I want you to find cosine. And then I've given you a location of where cosine is going, of where this triangle or ratio is taking place. So for starters, I'm going to draw a picture. I'm going to put the picture in the right quadrant because that just makes sense. I'm between pi over 2 and pi, which is 90 and 180. So I'm going to draw this triangle in quadrant 2. And I'm going to put my theta where the reference angle goes. And if I label the sides from my tangent, opposite over adjacent was 3, and then a 7. The 7 is what's negative since that was the x direction. So I'm going to find the hypotenuse by doing the Pythagorean theorem. So I'm doing 3 squared, which is 9, plus -7 squared, which is 49, and that gives me a 58. So the square root of 58, I'm going to see if I have any perfect squares in 58. And I do not. So square root of 58 is simplified and fine. So if I do the cosine of this theta, I do the adjacent side, which is -7, over the hypotenuse, which was radical 58. Remember, I am not as picky about you rationalizing these ones, but if you're comfortable with it, you can go ahead and do it. -7 radical 58 over 58. Notice the sign has to be negative here because we're in quadrant 2 with a cosine. So final answer could be either of these, I would accept. All right, another one, sine of theta is given. We're finding the tangent if we are in quadrant 4 because we're in between 2 pi and 3 pi over 2. So this is a quadrant 4 value that we're finding. I'm going to label my theta as the reference angle, and I'm going to label my sine. Opposite is the 8, and that would be my negative because it went down. Hypotenuse is 23. I'll use Pythagorean theorem and do 23 squared, and I'll subtract my -8 squared. That gives me a 465. And then just check to see if 465 doesn't seem to be a perfect square within there. So we're going to just leave that radical. Not always the nicest looking answers, I know. So now as we do the tangent of our theta, we're in quadrant 4, so it makes sense to get a negative here. The -8 is on top, that's the opposite. The radical 465 is on the bottom, that was the adjacent side. We could rationalize here if we were comfortable with it. So -8 radical 465 over 465. So again, I would accept either one of these answers. Okay, next. This was another one of our new problems. You're going to find all 6 trig functions for an angle theta using this as its given ordered pair on the terminal side. So I'm going to draw a picture I'm going to label 3, -6. So I'm going to be in quadrant 4. We went 3 to the right and down 6. And I need to evaluate for the sine, cosine, and tangent. And then I'll do the reciprocals as well. In order to find all my ratios, I do need my hypotenuse. So I'm quickly going to go ahead and do the Pythagorean theorem. 3 squared is 9, plus -6 squared is 36. So I get a radical 45 here. Now there is a perfect square of 9, so I'm going to bring out a 3 and then have a radical 5. So did some simplifying to get that radical. So the sine is opposite over hypotenuse. I'm going to reduce. And just for the sake of time and simplicity here, I'm just going to leave these in non-rationalized form, but feel free to rationalize these. Again, the only ones that it's an absolute must for are your unit circle ratios. All right, cosine of theta is adjacent over hypotenuse. And again, I'm just going to simplify the 3's here and get 1 over radical 5. Tangent is opposite over adjacent, and that will simplify to -2. So notice sine and tangent were negative, cosine was positive here. All right, so next I'm going to go ahead and fill in the reciprocals just by flipping. The signs will stay the same. And then the cotangent is going to be a -1/2. So there I used the triangle and I used the quadrant to get all of my 6 trig ratios. All right, so this last section, you were supposed to kind of time yourself and see if you could be able to do these 10 problems in under 5 minutes. Again, it takes some practice and some work with those ratios, but hopefully you're starting to be a little bit more familiar with them. So again, I'll just go through like I've been, talk you through this. I know this is a 60 degree. Sine of 60 is radical 3 over 2. I know 4 pi over 3 is in quadrant 3 where sine is negative. 315, it's a 45 degree angle. Cosine of 45 is radical 2 over 2. 315 is in quadrant 4, we're positive. This is a 45 degree angle. Tangent of 45 is 1. -3 pi over 4 is in quadrant 3 because we're coming backwards, and that's positive for tangent. 225 is a 45 degree. That's radical 2 over 2 for sine. Quadrant 3, negative for sine. Pi over 6 is a 30 degree. Cosine of 30 degrees is radical 3 over 2. We went backwards. We're in quadrant 4. Cosine's positive. A 30 degree here for tangent is radical 3 over 3. 5 pi over 6 is in quadrant 2 and tangent's negative. 120 is a 60 degree. And I know that the sine of 60 is radical 3 over 2. 120 is in quadrant 2 where sine is positive. This is a 60 degree. Tangent of 60 is just radical 3. 4 pi over 3 is in quadrant 3 and tangent's positive. This is 30 degrees. Sine of 30 is 1/2. 11 pi over 6 is in quadrant 4 where sine is negative. 300 is a 60 degree angle. And we said that the tangent of 60 is radical 3. Quadrant 4, though, for tangent is negative. So again, I know I can do those quick. Hopefully, eventually, you'll get there too. And just keep practicing. And we're going to